So 6.4.1 says if mn is equals to 6, determine the length of OT if t lies on the negative x-axis. Show all your working. So if t lies on the negative x-axis, as we can see from our function over here, we need to find the distance from O to T, or the length from O to T. And in order to do so, we need the coordinates, or the possible coordinates of T. The way we get those is we look at the way this 6 is expressed. This 6 is expressed as a distance from M to N. So in order to find, and we're also told that mn is parallel to the y-axis. That means it goes straight down, and the x value on this line is the same throughout. So we know that this is quite unique to the graph, at least unique to a point that allows us to calculate what possible x value that can be, because this won't occur at every x value. Not every x value will give us a difference between our points of 6. So with that information, we can say y, we're constructing a new function here, which is y is equals to x squared minus 2x minus 3 minus x plus 1. So here what we're basically doing is we're saying f of x minus g of x. So that's just subtracting the y values for the f of x, subtracting the y value of g of x. And we know in this particular case, the value that we get is 6. So 6 is equals to x squared minus 2x minus 3 minus x plus 1. We are looking for the x value that will give us a difference in the y values of 6. Or we're looking for the x values that will give us a length of 6 between our graphs. And that won't occur too many times. That will occur at most 2 times. Probably at most 3 times. But the other one will be negative 6 if possible, because the other one could lie somewhere in here. But that's all unnecessary for this question. All we need to do now is solve for x and choose the x value that applies most of all. So simplifying this, we'll have 6 is equals to x squared, then we have minus 2x minus x, that gives us minus 3x. Then we have minus 3 minus 1, that gives us minus 4. Then we can take 6 to the other side, becomes minus 6. We're going to have x squared minus 3x minus 10 is equals to 0. Then at this point, you can use your quadratic formula if you want to. Or you can solve it using the factors of minus 10. So the factors will be, we have 10 and 2, that's the pair, and 10 and 1, then we have 5 and 2. The one that's likely to give us minus 3 when we add will be 5 and 2, because we know minus 5 plus 2 gives us minus 3. So we can put minus 5 plus 2 here. And we also see that minus 5 times 2 gives us minus 10. And that is that x here will be equal to 5, or x is equals to minus 2. So how do I interpret my answers now? Basically, this is telling us that at x is equals to minus 2, if we subtract the y values in our functions, we get a difference of 6. Also at x is equals to 5, which will lie after this point because this is 4, 5 will be somewhere over there. And at that point, if we look at our function, this one will be somewhere there and that one will be somewhere there. And this difference between our y values again will be 6. So we are not interested in this one. We're interested in the one that will give us the coordinates for t, which is at x is equals to minus 2, which means at t, this has to be minus 2 as to 0. So with this information, we can easily now say that O2 will be equal to 2 units. And that's about it.